We have one question from the chapter application of derivative using the concept of maxima and minima. We need to show that a right circular cylinder of given surface area. So the surface area is fixed and maximum volume. That means we need to maximize the volume. In that case, it says that the height is equal to the diameter of its base. So let's say, for example, if I draw a cylinder first, let's say I draw a cylinder. I've drawn a cylinder. And I took this as the height and this being the radius of its base. And what we need to prove here that the height is equal to the diameter, which is nothing but 2r, is what we have to prove, right? This is something that we have to prove. And its surface area, what's the surface area of a cylinder? By default, it's going to be a total surface area, not given. That means if nothing is mentioned by default, we take as total surface area. So it's 2 pi RH, which is curved surface area, plus area of two circular base, which is 2 pi r square. Now we have these information over here, and let's see if I place it aside. Can be adjusted here. Now we can see that we have to maximize the volume, and a volume of a cylinder is pi r square h. We can observe here there are two variables. So I'm going to replace, say, h with in terms of a constant. So if I isolate h from here, if I isolate this h from here, so I can say that h on transposing 2 pi r square on the left hand side, it is minus 2 pi r square, and that divided by 2 pi r. So what you can observe here that h can be written like this in terms of s and r. Now I'll do substitution here. So it's v pi r square and h, which is mentioned here. I'm going to replace this h. So h can be replaced as s minus 2 pi r square, and that divided by 2 pi r. We can see here one r get cancelled, one pi get cancelled. And if I simplify it further, it's going to be, if I open this bracket, it is SR minus 2 pi r cube over 2. I can further split it and write as 2r over SR over 2 minus 2 divided by 2, and that is pi r cube. Now I'll find derivative. I'm differentiating here with respect to x. So if I differentiate with respect to r, not x. So this is dv by dr. Derivative of r is 1 and s over 2 is being coefficient. Derivative of this is going to be 3 pi r square. Now we'll also find its second derivative, that is d square v by dr square. As you know, we need second derivative test here. This being a constant, its derivative is 0 and minus 6 pi r. Now let's continue from here. Now we'll equate this for maxima or minima. What you know, for maxima or minima, the derivative, that is dv by dr, should be 0. dv by dr should be equal to 0. Equating this with 0, I can say s minus 2 minus 3 pi r square equals 0. So we can say s is equal to 6 pi r square. So we got this on. In turn, we can also say r square is equal to s over 6 pi r. We obtained this. Now we can say that r will be equal to s over under root 6 pi r. Oh, that's r, there's 6 pi, right? If I say r square, then it is r square is equal to r is going to be a under root of this. Now, here, after that, we are going to apply the second derivative test. Well, for applying the second derivative test, what we can say that d square v by dr square. As you can see that if I replace r with this, these are positive constant, right? And therefore, this whole thing will be positive, but there is a minus sign before it. So we'll say that it is less than 0. Hence, maxima at r is equal to under root 6 over, sorry, s over 6 pi. So we have proved that the maximum is attained when r is equal to this. Now, final thing that we had to prove was that the height is equal to the diameter of the base. That means we had to prove this thing, h is equal to 2r. Now, that's very easy. If I replace this s here, let's say if I do substitution over here, only replace erasing some part of it. All right. So if I replace s here with the value this, s is what? 6 pi r square. I replace this s, right, with this 6 pi r square. If I transpose this, that is 2 pi r square is equal to 2 pi r h. This is going to be 6 minus 2 is 4, that is 4 pi r square is equal to 2 pi r h. And that's what I got. So pi and pi get cancelled, 1 r get cancelled, and this get cancelled with 2 times. So in turn, we got 2r is equal to h. And we say that this is what we need to prove here.